Falling weight deflectometers are used by many states to help manage their pavements as part of rehabilitation analysis or network management. They are also used to help with forensic studies of distressed pavements. An FWD can also help evaluate soft sections of pavement, determine the transfer efficiency of concrete slabs, and facilitate the design of pavements from total reconstruction to the determination of overlay thickness. The speed of the FWD allows an agency to go down the pavement and test multiple points fairly quickly with limited amounts of time needed for traffic control, which is very expensive. The FWD can help determine the expected response of the pavement surface, and to some extent the response beneath the surface due to the passage of trucks and other large vehicles. It is critical that the data from the FWD be as accurate and precise as possible. Errors in the data will lead to errors in the pavement analysis. Without calibration, the bias error of an FWD could be as large as plus or minus 2% for each sensor. It is important to reduce these systematic errors in the deflection and load readings as much as possible. During FWD calibration, we can reduce the bias errors to about 0.3%. This greatly improves the quality of any pavement analysis.
Low pavement evaluation. This is Cal.
Hi, I'm interested in getting my FWD calibrated.
The first step in getting your FWD calibrated is to contact the closest calibration center to set up an appointment.
Now, I can tell you what you need to do before you get here. You need to make sure your FWD is well maintained and in good operating condition. You might look at your owner's manual. It'll set you straight on what you need to do, for maintenance on the unit. Yeah, I can also send you a checklist that some other items that you can go over before you get here.
It is important to fill out and properly follow the checklist sent by the FWD Calibration Center operator. This checklist contains typical maintenance activities that should be performed before leaving for the calibration center. If these steps are done prior to arrival, the calibration process will go much smoother and faster. If possible, drive to the center the night before the scheduled calibration. Once on site, get the FWD ready and warm it up. This is typically done outside, but sometimes it has to be done inside. Then drive into the calibration center facility and maneuver the FWD into position. First will be calibration of the FWD deflection sensors, and then the load cell. After this is done, paperwork will be completed to make sure the FWD has been set up properly before leaving the calibration center.
That's about it from this side, though.
One of the first steps after getting to the calibration center is removal of the deflection sensors from their holders. They have to be removed from the FWD and placed in stands used in the calibration of the deflection sensors. The sensors are usually removed by the FWD operators because they know their own machine and are usually more efficient at it than the calibration center operator. While the FWD operator is removing the deflection sensors, the center operator performs a daily calibration of the reference accelerometer used in deflection sensor calibration. This is done to improve the accuracy of the data from the accelerometer. Calibration of the deflection sensors starts with reference calibration versus the accelerometer. The goal here is to calibrate the sensors versus a reference device to ensure accuracy. This is done by placing the deflection sensors from the falling weight deflectometer along with the reference accelerometer in a large stand. A series of drops are performed where the reference accelerometer and the sensors from the FWD see the same deflections. After one trial is done, the sensors are rotated relative to the accelerometer and a second trial is completed. A third and fourth trial may be needed in some cases. The results from this reference calibration are used to create a series of interim gain factors for the deflection sensors. After reference calibration, the relative calibration improves the precision of the deflection sensor calibration. To accomplish this, a large number of drops are done with the FWD to tighten up the data. These results are used to produce the final gain factors for the FWD.
Bring it down.
The first step of load cell calibration is to make sure that the reference load cell is in line with the FWD load cell. This has to be done manually.
A little more. Okay, drop it. Excellent.
Before load cell calibration, the center operator adjusts the settings on the front of the signal conditioner. As with deflection sensor reference calibration, a series of drops are completed to calibrate the FWD load cell versus the reference device. The reference load cell is accurate enough that only a reference calibration step is needed.
Here you go.
Thanks, Dan.
Load cell 5.
Okay. Thank you. There it is. Those numbers look pretty good.
Nice.
Let's take a look at the graph. Oh, look at that graph. It's beautiful. Here's a copy of your calibration, Dan. It has the final gain factors on it. We'll need to input them in your computer. And sensor 3, you might want to keep an eye on it during the course of the year.
Okay. You want to read them off to me?
Sure. Sensor 1. 1.0.
The final step is to take the results from the calibration, put them back into the FWD, and make sure they were put in properly. The center operator and the FWD operator typically go over this information and documentation is produced. One of the reasons we calibrate falling weight deflectometers is to improve the quality of the actual data that we use in pavement analysis. Systematic errors in FWD data will affect the design. Using an overlay design as an example, underpredicted deflections could lead to a thinner overlay that may not last as long as planned. Overpredicted deflections may result in excess costs due to extra material being placed. These monies could have been applied to other projects. A recent study by the National Cooperative Highway Research Program on falling weight deflectometer usage by the state departments of transportation looked at the issues of calibration and the quality of the data collected. One of the studies they reviewed from Indiana showed that a calibrated FWD could save 24% in the area that had to be undersealed. This is a tremendous cost savings just due to having a calibrated FWD. Almost everybody can get their FWD to the calibration center within an 8-hour drive. With the current protocol, the FWD operator can drive to the calibration center, stay over just one night, calibrate the machine in the morning, and return home by that evening. Falling weight deflectometer calibration centers are located in Pennsylvania, Minnesota, Colorado, Montana, California, Texas, and Florida.